Okay, so this is question 19 in test 5, section 2 in the official SAT study guide. This is on page 643. So this is one of the last two questions, so you know that it's going to be fairly challenging. And if it has a triangle, odds are that this triangle is going to be one of your special triangles. So it'll probably be a 30, 60, 90 triangle or a 45, 45, 90 triangle, or it may be an isosceles triangle or an equilateral triangle. In this case, we'll see that it's a 30, 60, 90 triangle. Okay, so first we're told that triangle XYZ is equilateral. So that means that each of these angles has a measure of 60 degrees. And it also means that the side lengths are congruent. So these sides are all the same. And because this picture doesn't say figure not drawn to scale here, we can assume that this line dividing the middle of the triangle is creating two 30-degree angles at the top here. Because it looks to be dividing the 60-degree angle perfectly in half, and because it doesn't say the figure is not drawn to scale, we can assume that to be true. The question also tells us that this equilateral triangle has side lengths of 2. So that's really going to help us out, because then we have one side of the 30, 60, 90 triangle, because we know that these are 60-degree angles here. Okay. So let's just draw our 30, 60, 90 triangle and fill in what we know. We know the hypotenuse is 2. And if you look at the very beginning of the math section, so that'll be on page 638, then you can see that in a 30, 60, 90 triangle, the hypotenuse is equal to 2x. This side length down here is equal to plain old x, the side length that is opposite the 30-degree angle. And then we have our 60-degree angle down here. And the side length opposite the 60-degree angle will be x root 3. Okay. So based off of this, we know that x is 1. So then we know this side length and we know this side length. So let's just check out what they want us to ultimately find. They tell us that YW is the diameter of the circle and that the circle has center O. So they ultimately want the area of the circle. So the area of the circle is going to be half of the diameter. Sorry, not the area, the radius will be half of the diameter. And from that, we'll be able to determine the area. So we know with the work that we did earlier that the full diameter is root 3. So since root 3 is 2r, since the diameter is always 2r, then we know that the radius is root 3 divided by 2. And then we can plug that into our area of a circle equation. And we have to be just a little bit careful about distributing when we do that, because the area of a circle equation is pi r squared. And our r is a fraction, so we have to be careful to distribute to the top and to the bottom of the fraction. So that means that we have pi times root 3 over 2 squared, and this will get distributed to the top and to the bottom. So when we square root, it gets rid of the square root. So we'll have pi 3, and then the 2 is going to get distributed. So we have 2 squared in the denominator, which gives us 4. So our total area will be 3/4 pi, which we have here in choice C.